All right, today we're going to demystify something that's kind of like the hidden architecture of the internet, the OSI model. We're going to follow the wild journey your data takes every single time you're online. I mean, have you ever really stopped to think about it? You click a link and boom, almost instantly a web page pops up from maybe halfway across the world. What's the magic behind that? How does your computer's request navigate the entire messy internet to find the exact right server and bring the answer all the way back to you? That's the puzzle the OSI model helps us solve. So, to make sense of all this chaos, the tech industry needed a common framework, right? A universal language everyone could use to talk about the networking process. And that's exactly where the OSI model comes in. The Open Systems Interconnection model, or OSI for short, isn't a set of rules you have to follow or a specific piece of tech. It's a reference model. Think of it like a blueprint, a conceptual framework that helps us all understand and talk about how networks actually work. And you know what? It's still incredibly relevant today. It maps perfectly to the TCP/IP protocols that power the whole modern internet. Yeah, a great way to think about it is like this. It's the Rosetta Stone for network engineers. It lets someone in your company talk to a technician from a totally different organization. And when they say, hey, I think we've got a layer 3 problem, everyone knows exactly what that means. No confusion. It creates a shared understanding. Okay, so the heart of this model, the thing that makes it so useful, is its structure. It's all broken down into 7 distinct layers. Each layer has a very specific job to do, and together, they formed a complete roadmap for our data's journey. And here they are, all 7 of them. We're going to list them from top to bottom, starting with the one closest to you, the user. We've got the application layer, then presentation, session, transport, network, data link, and finally, all the way at the bottom, the physical layer, the actual cables and signals. Okay, I know what you're thinking. Memorizing all those in order, that sounds kind of tricky. But luckily, there's a fantastic little mnemonic that people have used for years. Just remember this phrase. All people seem to need data processing. It's a super simple way to keep those layers straight from 7 all the way down to 1. All right, let's actually follow a piece of data on its journey. When you send an email or load up a web page, your data starts at the very top, at layer 7, and it travels down the stack. This whole process has a name. It's called encapsulation. Encapsulation? It sounds complicated, but it's a lot like sending a package through the mail. You write a letter, right? That's your data. You pop it in an envelope. That's one layer, adding some info. Then you write an address on it. That's another layer. And finally, you hand it to the mail truck for delivery. That's yet another layer. See? Each step just adds the necessary information for the next part of the journey. So let's start at the tippy top with layer 7, the application layer. This is the one you actually see and interact with. We're talking about your web browser, your email client, your online games. All those protocols you might have heard of, like HTTP for websites or FTP for file transfers, they all live right here. Just below that, we've got layer 6, the presentation layer. This one acts like a universal translator. It takes data from your application and gets it into a format the network can understand. This is also where some really crucial security stuff happens, like the encryption and decryption you get with SSL/TLS. Basically, it makes sure the data is both understandable and secure. Then we come to layer 5, the session layer. You can think of this as the communication manager, or maybe the traffic cop. It's responsible for opening, closing, and managing the entire conversation or session between your computer and the server. It makes sure that connection stays open and stable for as long as it's needed. Okay, now we're at layer 4, the transport layer. I like to call this the post office of the OSI model. Its main job is to get your data from your computer to the server, and to do it reliably. It has 2 main ways of doing this. TCP, which is for reliable, error-checked delivery, kind of like registered mail. And then there's UDP, which is faster, best-effort delivery, more like a standard postcard. This layer is also the one that chops up big files into smaller, more manageable packets for the trip. Next up is layer 3, the network layer. This is all about routing. So while layer 4 is about getting the data from end to end, layer 3 figures out the best path it needs to take across all the different networks in between. This is where IP addresses live. Routers, those little boxes you have at home, they operate right here, looking at the destination IP address to decide where to send the data next. So if you're ever troubleshooting a routing issue, you're working at layer 3. Dropping down another level, we hit layer 2, the data link layer. This is sometimes called the switching layer. Now, this layer handles communication between devices that are on the same local network. So think about it this way. Layer 3's IP address is like your home's street address that the whole world can see. But Layer 2's MAC address, that's like your name inside your own house. It's only used for local delivery. Network switches work here, using these MAC addresses to shuttle data to the right device on your Wi-Fi or your wired network. And finally, we've made it to the bottom. We're at the foundation, Layer 1, the physical layer. This is the actual hardware. We're talking raw bits, the ones and zeros, flying around as electrical signals over a copper cable or as pulses of light in a fiber optic line or even as radio waves through the air. You know, if your internet suddenly goes out, the very first thing you check is Layer 1. Is the cable plugged in? That's a physical layer problem. Okay, so that's all the theory, but what does this stuff actually look like in the real world? Let's put on our network detective hats for a second and decode some real traffic to see these layers in action. To do that, we're going to use a really common network analysis tool called Wireshark. You can think of it like a microscope for your internet traffic. It lets us capture a network packet as it flies by and just peek inside, seeing all the information that was added at each layer. It shows us exactly how this theory works in practice. It's pretty cool. All right, check this out. Here's the first part of our decode. See where it says Ethernet 2? That's a Layer 2 protocol. And look, right there, you can see the source and destination MAC addresses. Those are the hardware addresses that are directing this packet on the local network. Okay, let's drill down a bit deeper. Inside that Ethernet frame, we find the Layer 3 information. See? Internet Protocol, or IP. And just like we talked about, here are the source and destination IP addresses. These are the addresses that routers all over the internet are using to guide this packet to its final destination. And if we look inside that IP packet, we find Layer 4, the Transmission Control Protocol, TCP. This section has the source and destination ports. And that destination port, number 443, is super important. It's telling the receiving computer, hey, send this data to the web server application that handles secure HTTPS traffic. It's like the specific apartment number in an apartment building. So you might be wondering, hey, wait a minute, where are the top 3 layers? Session, presentation, application. Well, in the real world, especially when traffic is encrypted, layers 5, 6, and 7 are often all bundled together. In this case, they're all contained inside the secure data payload itself. That single encrypted package handles the session, the data format, and the application request all in one go. So after that whole journey, from top to bottom and back again, why does learning this model actually matter so much? I promise it's not just for passing a certification exam. It's a really fundamental tool for anyone working in tech. When you boil it all down, the OSI model gives us 3 incredibly powerful things. First, a common language so IT pros can communicate clearly. Second, a structured, step-by-step approach to troubleshooting. And third, it's a universal standard that applies to all network tech, no matter who made it. It really does turn chaotic network problems into a logical, step-by-step investigation.
So, there you have it. You now have the map that every single piece of data on the internet follows. It's the hidden architecture of our digital world, unveiled layer by layer. The only question left is, now that you've got the map in your hands, which layer are you going to explore next?